What if I told you that the safety of your food doesn't just depend on hygiene or quality control staff, but on machines working 24/7 in sterile environments, making decisions in milliseconds? From packaged snacks to bottled drinks and canned goods, PLCs, programmable logic controllers, are the silent guardians of the food industry. They control everything from temperature and pressure to batch tracking and labeling. But how do they actually do it? How does a machine know when a batch is sterilized or when a label is wrong? Can automation really replace human inspection? And how do you prove your food was safely processed weeks or even months after it's made? In this video, we'll open the doors to modern food factories and show you how industrial automation makes food production faster, cleaner, and safer than ever. Do you want answers? Watch the full video to get them. The food industry isn't just about taste or packaging, it's about compliance, safety, and consistency. And here's the truth. When you're producing millions of units per day in hundreds of different formats across global markets, you can't rely on manual processes anymore. That's where automation, and specifically PLCs, step in. In food manufacturing, companies are bound by strict global regulations like HACCP, Hazard Analysis and Critical Control Points, ISO 22000 Food Safety Management, FDA and USDA protocols, especially in the US. What do these regulations demand? Complete process traceability. Every product must be linked to its batch, temperature cycle, and production time. Absolute hygiene. No room for contamination, especially in sterilization and filling zones. Real-time control and correction. The system must detect and respond to deviations instantly. That's where PLCs become essential. These aren't just glorified timers. They're the digital backbone of food plants, making decisions every millisecond. They manage temperature controls during cooking and sterilization, valves and pumps during filling or mixing, weight checks and optical inspections during packaging, alarms, cycle reports, and lot tracking for audits. And here's something you might not have thought about. In most modern food plants, the fewer people who touch the product, the safer it is. Automation drastically reduces human contact while improving consistency, repeatability, and safety. So now that we know why PLCs are crucial, let's look at how they work in a real production line. Canned food. So how does a real food production line work, with automation handling everything from raw ingredients to finished cans? Let's break it down step by step and see where the PLC fits into each one. Step 1. Raw material loading. It all starts with ingredients, vegetables, meats, sauces, delivered in bulk. As each batch arrives, sensors verify weight, quality, and temperature. The PLC logs the batch ID, associates it with the production lot, and sends the signal to move the ingredients into automated washing or prep tanks. From this point on, the system knows exactly what's going into every can, and it tracks it every step of the way. Step 2. Automated washing. Hygiene is priority number 1. The system opens and closes valves that control water flow, pressure, and temperature. Spray nozzles and rotating drums clean every surface, timed by the PLC to ensure full sanitation. All this is logged: cycle duration, temperature peaks, flow rates. If something doesn't meet the defined parameters, the batch is rejected before it ever enters production. Step 3. Cooking or sterilization. Depending on the product, this can be done via industrial cookers, pasteurization tunnels, or autoclaves. Here, PID control comes into play. PID stands for Proportional Integral Derivative. It is the method PLCs use to precisely regulate variables like temperature and pressure. The PLC continuously monitors cooking time, internal temperature of the product, pressure inside the chamber. If anything drifts even slightly, the PLC adjusts in real time. Need to hit 121 degrees Celsius for 15 minutes under 15 psi? The PLC does it automatically, every time. Step 4. Filling and capping. Now that the product is sterile and cooked, it's time to fill the cans. Filling stations are equipped with load cells for weight control, flow meters for liquids, servo-driven nozzles for speed and accuracy. Each station talks to the PLC, which adjusts fill volume on the fly if conditions change. Once filled, capping machines seal the cans. The torque applied to each cap is measured digitally. and any cap that doesn't meet the required spec is flagged and removed without stopping the line. Step 5. Labeling and coding. Next up is labeling. Encoders synchronize label placement with conveyor speed. The PLC coordinates the printhead, ensuring each label includes the correct batch number, expiration date, and even QR codes or region-specific info. Every label is scanned by machine vision. Smudged, misaligned, wrong lot number? The PLC removes it instantly, no human required. Step 6. Final quality control. Finally, before cans are packed into boxes, they pass through automated inspection systems. Vision systems check for dents, fill level, label alignment. X-ray or weight checkers scan for missing contents. Air pressure sensors verify lid integrity. Any rejected cans are diverted, counted, and logged, with all data tied back to the original batch. And through it all, the PLC is the conductor. It's scanning every input, executing thousands of logic conditions, sending commands to actuators, motors, and valves, recording everything into the SCADA or MES system for traceability. Every second, it's making decisions faster than any operator ever could. And the result? Food that's safe, consistent, and compliant, with zero compromise. If there's one part of food manufacturing where failure is not an option, it's sterilization. Because whether you're making baby food, canned beans, or ready-to-eat meals, improper sterilization can lead to contamination, product recalls, or worse. This is where PLCs and automation truly prove their value. Take an autoclave or pasteurization tunnel. These machines are responsible for killing bacteria by maintaining exact temperature, pressure, and exposure time. Here's what the PLC controls: the moment heating starts and stops, the steam or hot water flow rates, real-time pressure inside the chamber, the duration each product stays inside. And it's not just about hitting a temperature, it's about staying there precisely for the required time, with no deviation. The PLC continuously adjusts valves and heating elements using PID loops, reacting in milliseconds to sensor feedback. If a sensor detects a drop in temperature, even by half a degree, the PLC corrects it instantly. And all of this is logged: cycle start and end times, peak temperatures and pressure curves, any alarms or manual overrides. This means you're not just sterilizing food, you're proving it, with digital records you can present during audits or certifications. In the food industry, traceability is everything. Let's say a customer calls with a complaint. Can you prove exactly when that can was filled, what batch it came from, and which sterilization cycle it was part of? With PLCs, the answer is yes. Each unit gets assigned a lot number, automatically printed or labeled by the system. That number is tied to the raw materials used, the process parameters recorded during production, any alarms, slowdowns, or rework that occurred. And it doesn't stop there. In some factories, PLCs feed data directly into SCADA or MES systems, creating a real-time production map. Batch genealogy, performance metrics, alarm history, cleaning cycles. This allows teams to investigate quality issues, respond to recalls fast, prove compliance to regulators, and continuously improve the process. And remember, all of this happens with minimal human input. Let's recap what automation brings to the table. Cleaner production by reducing human contact. More consistent results, every cycle, every can, every shift. Stronger compliance, built-in traceability and digital records. Higher efficiency, faster product changeovers, smarter cleaning, CIP, and reduced downtime. Better safety for the product and the workers. And all of it is powered by a system that's smart, fast, and never takes a break. The PLC. So the next time you grab a packaged meal, open a can of soup, or enjoy a cold drink, remember this: behind every safe, clean, and reliable product is an invisible layer of logic, working in real time to make sure that food is exactly how it should be. And at the center of it all, automation, precision, PLCs. If you've worked in food automation or want to get started, tell us your experience in the comments. What systems do you use, and what challenges have you faced? And don't forget to subscribe for more in-depth looks at how the world of industrial automation works, factory by factory, In our next video, we'll teach you how to read PLC manuals, data sheets, and wiring diagrams, so you can move from theory to practice. This video is produced by Autom8, the platform that connects automation companies and PLC programmers across the globe. Visit autom8deal.com to find talent, get hired, and grow your automation business.